Hello and welcome to another video. In this video we're going to be working on continuous sum array sum. And in this one you have an integer array nums and an integer k, and you want to return true if nums has a good subarray or false otherwise. A good subarray is where the length is at least 2 and the sum of all the elements is a multiple of k. And subarray is a contiguous part of the array, and x is a multiple of k that's pretty straightforward. So in this first example there is a good subarray, this one right here, and there's also this one right here that is a multiple of k, so it's true. In the second one, same thing, this is 1 as well, and I guess the whole thing is 1. And the third one, there's none. So this is very similar to, I think there's a problem called like subarray sum equals k. So just look at a subarray like this. So let's just say instead of looking for a subarray that is a multiple of k, let's just say we're looking for a subarray that equals k. So how would we do that? So for that one, you can actually use prefix sums and maintain a running total. So what you would do here is you would say, okay, let's just write down our running totals for this array. So it would look like this. So we have 23, 25, 31, 35, and 42. So for this one, basically you're looking for two numbers that have a difference of k, because if two numbers have a difference of k, that means the subarray between those equals k. So for example, these two have a difference of k, so that means the subarray between those equals k, and the subarray between those is just this number here. And you should have a couple more. So these two numbers also have a difference of 12, so the subarray in between those is also equal to k. Actually, no, it won't equal to k in this case. So you have to actually have an exact difference. So this is going to equal 6, and actually that might be it. Yeah. So that's how you do like subarray sum equals k. Just quickly, if you haven't seen it before, you basically do prefix sums, and then you look for like whatever number you're on. You look for, do I have that number minus k? So if I have a 31, if I have a 26. That means the subarray between the, or it wouldn't be 26, it would be 25. The subarray between the 25 and 31 has to equal k, because we got from a 25 to a 31, which means whatever subarray we traverse to get from this to this has to equal 6, so that's true. But how do we change this? Like what do we need to store here instead to do a multiple? Well, if a subarray equals k, that means that whole subarray equals k. Right? But what if a subarray is a multiple of k? What does that mean exactly? So if a subarray is a multiple of k, like what do we store instead of? Because here we just stored a sum, but here do we just store like what do we need to store instead, basically? So if a subarray is a multiple of k, that means that subarray mod k equals 0. Okay. And so basically this problem comes down to knowing a little bit about modulo arithmetic. And so let's just say let's look at, instead of subarrays, let's just look at a couple numbers. So let's say our k is 5. And so obviously if our subarray has sum 25, let's say, then this is fine, and this is a multiple of k. But let's look at what happens in one other thing, and this is going to be like the main thing for this problem. So 25 mod 5 equals 0, but what if we just take two numbers that mod k are the same? And what does that mean if you think about it? So if we take two numbers, let's say that, like, so we take x mod 3, or x mod k, and y mod k, where the results are the same. So for example, let's just pick two numbers where x mod k is 3 and y mod k is 3. So let's say we can take like 13, and we can take one more, right? So like 28. So 28 mod 5 is 3, 13 mod 5 is 3. Well, if two numbers mod k are the same, that means to go from one number to the other, you basically add k some amount of times. Because if k is 5, right? So if we can draw this, so if k is 5, you can think about it like, okay, 1 mod k is 1, 2 mod k is 2, 3 mod k is 3, 4 mod k is 4, then this is 0, and then it loops around again, right? So it's like 0, 1, 2, 3, 4, and then it will loop again, 0, 1, 2, 3, 4, and so on and so on and so on and so on. So this will be like 6, 7, 8, 9, 10. So if two numbers, if you're dividing by the same number, have the same remainder, that means you added that number that you're dividing them by, because the remainder will keep changing by 1, and then it will reset, and then it will keep changing by 1, and so on. So if like these two numbers, notice that we divided by 5 here, so these two numbers have a difference of a multiple of k. These two numbers have a difference of a multiple of k. And if you keep doing this, like if I draw this again, like 11, 12, 13, 14, 15, and so on, it will basically keep repeating, right? So if we have this, and then we can probably just copy this actually and put it right there. So once again, this will keep repeating, and now this will be 11, 12, 13, 14, 15. So hopefully this makes it clear that when you divide a bunch of numbers by the same number, if the remainder is the same, that means the difference between those two numbers is the different number you divide them by. So if we take a 2 and a 2 here like this, you could see like 3 and 18 have a difference of 15, which is a multiple of k. 19 and 4 have a difference of 15, which is a multiple of k, and so on and so on. So you can keep growing this. So essentially, this is what we need to be storing. We need to be storing our total mod k, and then if we've seen that before, then we have a subarray that is a multiple of k. So let's store that in here. So here we have 23 mod k, which is 3. Then our total is 25, mod k is 0. Then, or actually, so sorry, in this case, k is 6. So let's write that down. Okay, here we go. So k is 6, so this is actually 5. Then we have 25, mod 6 is 1. Then 31, mod 6 is 1. Then 35, mod 6 is 5. And 42, mod 6 is 0. Okay, and also, just like in a subarray sum equals k, you want to say that like the initial mod k is 0. So for the empty array, the mod k is 0. Because then you'd say like, oh, I've seen 0 here and I've seen 0 here. So this whole array, mod k is 0, this whole array right here. So as you can see, there's like a bunch of subarrays with a subarray being a multiple of k. So one is this case, which is this number here. One is this case, which is this number here. And one is the whole thing, which is this number here. And basically all you're looking for is when you're on a number, we can just store the index where we saw that number. And as long as the previous index is more than 1 away, because they want an array of length 2. So for a prefix sum, when you have this minus this, when you have like an end minus start, it actually represents the array of the number after the start to the end. So like if these are the same, it actually represents the array of just this guy. And if these are the same, it represents the array of just this guy right there. And if these are the same, it represents the array of just this guy. So basically, these two wouldn't work. And notice that's the case because just a number 6 wouldn't work. You want an array that's longer. And let's say the last part of the problem is, let's ignore this whole array. Let's say we have something like this. So this is just going to be like the remainders. So what happens if we have a 1 here and then we have a 1 here? And notice how these aren't far enough apart. So but what would we want to store? Like we've seen a 1 in index 0 and we've seen a 1 in index 1. And we know that this is not an array of length 2, this is only an array of length 1. Should we store both of these locations? Should we just store one? Well, the question just asks, is there a subarray? So we don't need to store all of them. So if we don't need to store all of them, what we actually only want to do is store the first location we've seen a remainder. Because if these two are the case, if I see it again, I just want to store the first one because that would give me the longest array possible. So I don't care about this guy. Like this, we don't need to store this. We just need to store the first one, and then we'll be like, okay, we've seen it before. Is it 2 away? Yes, it is. So that's kind of the idea. So that's basically all we need to do is we're going to maintain a running total. We're going to store the location of total mod k, and then we're going to see have we seen it before, and if we have, it needs to be more than, the index difference needs to be more than 1, and if we have seen it before and it's already stored, we don't need to like store another location. We only need to store one of them, because if there's a bunch of ones, we only care if there's one subarray possible, and there is one subarray possible as long as the remainders are the same, and as long as the distance between these two locations, whatever you pick, is more than 1. Okay, so hopefully that makes sense. If not, you should first do the subarray sum equals k. I think it's a pretty common problem. And then do this one. So let's do that. So all we need is a hash map of the number mod k and the location where that happened. So we're going to say map integer locations. And like I said, we're going to store the empty array. So the empty array mod k is 0, and that's going to be at index -1. Because let's say the first number is 0 in our array. So like in this array, if the first number was 0, then this total would be 0 as well. And then we have 0 and 0, but these are not 2 away because this will be at location -1. But if we are 0 and 0, then that would work because that would make an array of like 2. So we're going to say locations put the remainder 0 at -1. Now we need to loop through all our numbers. So and we need to store 2 things. So we need to store a cumulative total. We don't need to store that in like an array. We can just keep track of it. And we also need to get the number mod k. So we can say like total plus equal nums I. And the mod or remainder equals number or total mod k. And if we've seen the remainder, so if locations has it, if it was there, then we just need to get the like where we've seen it, and as long as it's 2 apart or more, we return true. So if I minus locations dot get remainder is greater or equal to 2, because that would make an array of length 2, we can return true here. And so you can slightly modify like what you're storing in this hash map depending on what you want. Like if they want all subarrays, instead of storing the first location, you would store all. If they want the count of subarrays, you would just store a number of how many you've seen and so on. So with slight modifications, you can get whatever you want here. So if we have seen the number, we want to do this. And if we have seen the number and this isn't the case, then we just do nothing because we want the first available location. Otherwise, we put it in our hash map. So put this is going to be remainder and at I. And if we went through this whole thing and weren't able to find a pair that was 1, 2 away, we just return false. So there we go. Let's see the error. Cannot find symbol. No. Okay. So yeah, you just have to know some basic modular arithmetic. Know that like if I have multiple numbers that mod to the same thing, the thing between them, you're basically you have to add a multiple of the number you're dividing by to get the same remainder. And I think by looking at a picture like this, it makes a lot of sense of why that is. So hopefully that makes sense. So let's go through the time and space. So time, we're just looping through our numbers. That's O of n. Space. So space or hash map size is going to be based on k, right? So if k is small, then we're going to keep like deleting the thing. So we can have any remainder from 0 to k minus 1. So it's going to be O of k. Actually, let's take a look how big k is. So k is 2 to the 31. So it's not going to be O of k. It's going to be O of minimum of k and n. Because if there's only 3 numbers, you can't have, you know, like let's say k is 2 to the 31 and there's 3 numbers. You're only going to have 3 in here. Yeah, so I think that's everything for this one. Hopefully it made sense. If you have any questions, you can write in the comments, and I'll see you in the next one. Thanks for watching.